On part 2 of our chemical nomenclature, we will begin looking at naming polyatomic compounds. Now, a polyatomic compound is a compound that's made up of 3 or more elements. Now, with the 3 or more elements, we will have this divided up where one group of elements will act as the cation, or the positively charged structure, and we will have one group of elements that will act as the anion, or the negatively charged structure. You will have a chart that will be given to you in class. We typically name that the Fat Daddy chart, and this chart will have a list of the charges and the formulas for some of the most commonly used polyatomic ions. Now, this is a chart that has some common polyatomic ions on it, and when we look at it, just to show you how this works out, NH4 with a +1 charge stands for ammonium. And so this right here, this NH4 +1, is our cation in a chemical formula. NO2 with a -1 charge stands for nitrite, and that would act as an anion in a chemical compound. And so you will see a list of the different polyatomic ions, and you will see their charges listed. Now, we will use these in our upcoming examples, so that when we name a polyatomic compound, what we do is we're going to name it just like we would a binary compound. So we look this right here up, and we look from our previous chart, and we know that NH4 stands for ammonium, so we would write down the word ammonium. We would find the C2H3O2 on our chart, and that stands for acetate, and so we would simply name this ammonium acetate. Now, as I solve these examples on this page, do know that when I say that we are referring to a chart, it is a chart that is 2 slides back. Now, we know that NaOH is a polyatomic compound. It's made up of sodium, oxygen, and hydrogen. And just to figure out what's going on, I find that this right here shows up on that chart 2 slides back, and the OH stands for hydroxide. So I would name this sodium hydroxide. On this next example, I have MgNO32. Now, where this 2 came from, that's going to be a little bit later on our next video series. But let's just go with what we have here. The Mg stands for magnesium. My chart back a couple of slides back, NO3 is nitrate, so we would name this magnesium nitrate. This next example, the NH4 from our chart is ammonium. Our SO4 is sulfate, so we would name this ammonium sulfate. Now, this 2 has to go along with balancing out our equation. We're going to explain why we have this in our chemical compound a little bit later on. Now, here we have FePO4. Now, Fe is a transitional element. So just with our like with our binary compounds, we will need to include a Roman numeral to indicate its charge. The PO4, when we look at the PO4, that is phosphate. And if we look back at that chart, it had a -3 charge. Now, it brought that -3 charge over here. Remember that we have a 1-to-1 ratio where we have 1 iron to 1 PO4. Now, if we have 3 as our charge for our phosphate, we would have to have a +3 for our charge for our iron. Therefore, we would have an iron 3 phosphate for our name. Now, here I have a flow chart for naming the compounds, the binary ionic, the binary covalent, and the polyatomic. And if you find this flow chart or this review helpful for what we've covered on part 1 of nomenclature and on the polyatomics, then print this page off. But I have written 4 examples here to show you how to use this flow chart. Now, we're going to look at number 1. And as we look at number 1, I'm going to go through a series of questions for us to answer yes or no. So we're looking at number 1, N2O5. Does the formula begin with H? Well, the answer is no. So we follow down. Does it begin with a metal which has more than one oxidation number? In other words, a transitional element, or the element tin or lead. This is nitrogen, so the answer to that's no. Does it contain a polyatomic ion, more than 2 elements? No, it does not. Are both of these nonmetals? And nitrogen's a nonmetal and oxygen's a nonmetal, so the answer is yes. Well, we're going to name the first element and we're going to use a prefix, so dinitrogen. And then we're going to name the second element, we're going to use a prefix, and we're going to change the ending to IDE. So that's oxygen. Prefix is pent, so we would have pentoxide, and therefore we would name this dinitrogen pentoxide. Let's look at example number 2. Does that element, that compound, begin with H? No, it does not. Does it begin with an element which has more than one oxidation number, a transitional element, tin or lead? No, aluminum does not fall there, so the answer is no. Does it contain polyatomic ions? No, there's just 2 elements present. Are both of these nonmetals? No, aluminum is a metal, oxygen is a nonmetal. So we'll name the first element aluminum, the second element with an IDE ending, aluminum oxide. Now let's look at example 3. Does it begin with H? Nope. Does it contain a metal with more than one oxidation number, a transitional element, tin or lead? Yes. Fe is a transitional element. So we're going to name the first element followed by its oxidation number, Roman numeral, and then we're going to name the second element with an IDE ending. So we would name this iron. Now to get its charge, it brings its charge over, so its charge would be 3 sulfide. And remember that they trade charges, and therefore we always have to look at what it brought over. And so this would be iron 3 sulfide. Number 4, our last example. It does not begin with hydrogen. Ca is not a transitional element, so no, it does not need Roman numerals. It is a polyatomic, so we'll come over here. We'll name the first element, and that first element is calcium. And then we're going to look up on the chart and see what that next one is, and SO4 is sulfate, so we would name this calcium sulfate. And so I encourage you to use this chart if it is helpful to you. And just review over this chart with some examples in front of you, and you can spot check and see how you're doing. If you run across any questions, you can rewatch the videos, or as always, you can come by my classroom for help. Now, how about those chemical compounds that do begin with H? Those chemicals that begin with H are classified as acids, and there are a set of rules for the nomenclature of acids, and we're going to use this flowchart for naming the acids. So what we will do is, if it begins with H, it's an acid. And now we're going to look at the second set of elements that is in the chemical equation. And so as we look at these, we're going to look at, does the anion contain oxygen? If yes, then we're going to look the anion up on our chart from our slides back. And if that substance ends in ITE, then we're going to drop the ITE ending, add OUS, followed by the word acid. If that chemical compound ended in 8, we're going to drop the 8, we're going to add IC, followed by the word acid. Now, if oxygen is not present, we will use the prefix hydro, the anion name, IC ending, followed by the word acid. What did I just say? Well, let's look at some examples, and I believe we'll make this a lot easier. So let's look over how we would name these various acids. Now, the first thing that we'll notice is that each one of these chemicals that we're looking at begins with H, so they are an acid. Now to name those, we're going to be using our polyatomic chart, and we're going to be using that flow chart. Now it begins with H, so we know that we have acid. We're going to be looking at this NO2 portion. Now when we look up the NO2, we will see that that's nitrite. So we come over here. Does our anion contain oxygen? Yes, it does. So we checked the ending and we saw it was nitrite, so we had an IT ending. So we're going to name the anion. So we have nitrous followed by the word acid, and therefore we get nitrous acid. Now let's look at this next one. It begins with H, so it's an acid. We look up, it does have oxygen, so we're going to come over here, and then we need to look up and see, does this have an IT or an ATE ending? And so right here we find SO3, it has an IT ending. With the IT ending, we're going to name the anion, so that's a sulfite, drop the ITE, add OUS, followed by the word acid, sulfurous acid. Again, we've got hydrogen, it's an acid. We've got oxygen, we need to look this up. We have it right here, that's chlorite. So again, we're going to drop the ITE ending followed by the word followed by the ending OUS and the word acid, chlorous acid. Now on these over here, each of these begin with H. We look these up. NO2 is nitrate. Now all of these are going to follow under this direction here. So we're going to name it as nitric acid, dropping the ATE followed by the word acid. Here this would have been sulfate, therefore this would be sulfuric acid. The C2H3O2, some students have trouble finding that one, and that's right here, that's acetate, acetic acid. On this example here, we're going to follow in this direction. So we have all of these being acid, they begin with H. It does not contain oxygen, so we're going to use the prefix hydro. Now this is chloride. We're going to change the ending to IC followed by the word acid. So here we have hydrochloric acid. CN is cyanide, and we would find that right here on our chart. So this would be hydrocyanic acid. H2S, S is sulfide, change it to sulfuric, so hydrosulfuric acid. And that's just a quick review over how to name our acids.